Vince reads that cars are a major source of air pollution. He decides to look at his family's driving habits. They have 2 vehicles, a car and an SUV. His parents estimate that the family drives about 1,200 miles each month. They decide to limit their driving to no more than 1,000 miles each month. Find 10 possible car miles, SUV miles pairs that give a total of no more than 1,000 miles. 1 month, the family drove the car 500 miles and the SUV 500 miles. Was the total for this month no more than 1,000 miles? Yes. Other combinations would be 700 miles and 300 miles, 600 miles and 400 miles, or 200 miles and 800 miles. Let's look at the pattern of the plotted points. Well, first we need to plot the 10 points we found in the getting ready. Well, let's look at these and see. They could drive the car for 0 miles and the SUV for 1,000. They could drive the car for 100 miles and the SUV for 900. The car for 200 miles and 800, 300 and 700, 400 and 600, 500 and 500, 600 and 400, and so on. Are there any other possible car mile pairs that get a total of no more than 1,000 miles? Yes, we just plotted these on the grid. Now we can connect these points and we refer to the part of the graph or plane as a region, and that would be all of these points on the graph. The points are located in the lower right hand, lower left hand part of the graph that show no more than 1,000 miles. In what region are the points that do not meet this condition? In the upper right hand. Suppose Vince's family wants to limit their driving to at most 800 miles per month. You're going to be asked to draw a graph of cars and miles that meet this condition. Describe the region of the graph that includes all points that represent a total of no more than 800 miles. So let's see. If we wanted to draw our graph, it would look a lot like the graph above. Here. And we want the car to go no more than 800 miles, both vehicles. So our x-axis is going to stand for the car miles, and the y-axis is going to stand for or represent the SUV miles. And I'm going to go ahead and label each whole number is going to represent 100 miles. And you need to be writing down everything that I write down. All right, how can we draw a graph with points that are no more than 800 miles? They could drive the car 0 miles and the SUV 800 miles. They could drive the car 100 miles and the SUV 700. 200 and 600. 300 and 500. 400 and 400. 2 and 1. We would connect these points here. And then we're going to shade in the region that represents all of the points or the mileage that is no more than 800 miles. Letter D, write inequalities to model the situations in B and C. Well, since we're using two variables to represent our data, I'm going to write question B. If X is going to represent the car mileage and Y is going to represent the SUV mileage, it has to be less than or equal to 1,000 miles. For question C, X will represent the car mileage, Y will represent the SUV mileage, and it has to be less than or equal to 800 miles. We use graphs to represent these situations and where there are too many data points to list. That's why we graph our data. All right, let's look at Vince finds out that his family's car emits an average of 7,500 pounds of carbon dioxide per mile. The SUV emits an average of 1 in 2,500 pounds of carbon dioxide per mile. Now this is a little different because there our X and Y values are going to have coefficients. Suppose Vince's family wants to limit their carbon dioxide emissions from their car to at most 600 pounds per month. How many miles could they drive their car? Well, their car emits 75 hundredths of a pound per month. And they want to limit that to at most 600 pounds. So this would be the inequality we would write to solve for how many pounds of carbon dioxide the car would emit. And the car could only be driven at most 800 miles. So the car has to be driven. X is less than or equal to 800 miles. Now let's look at the SUV. He wants to limit the carbon dioxide emissions from their SUV to at most 600 pounds per month. So that inequality would be 1 in 2,500 hundredths. X is at most less than or equal to 600 pounds. So they can drive the SUV 480 miles. I'm going to erase the equal sign and replace it with an less than or equal to. Now here is suppose they want to limit the carbon dioxide emissions from both vehicles to at most 600 pounds per month. What are some car miles and SUV mile pairs that allow them to meet this condition? So, what we're looking at here is a system of inequalities and we need to figure out ordered pairs that we could plug in for our X and Y values that can give us less than or equal to 600 pounds. So go ahead and pause the video and think of 3 ordered pairs that would meet this condition. Okay, the 3 ordered pairs that I found to meet this condition are listed. And how I found this first ordered pair of 300 and 200 is I plugged in 300 for X, 200 in here for Y, used order of operations and got 475 miles is less than or equal to 600 miles. So that ordered pair meets that condition. 200 and 300 does as well, and so does 400 and 200. You may have something different than mine. Okay, so the 6 examples that I found are written here below. An equation to model this situation would be (7/500x plus 1 25/100 y equals 600. Graphing this equation. Okay, now I'm going to model how to do this right here, and then I'm going to let you and a peer buddy do the rest, and then finish the rest for homework. The answers will be on Tuesday's home classwork video. All right. When we graph any equation, we have to solve for y and put it into y equals mx plus b form. If you look at our equation now, our equation is in standard form. So we need to go ahead and solve for y so that we can graph this equation. Alright, I'm going to solve for y over here and then we'll graph it together. To solve for y first, we have to get 1 25/100 y is equal to negative 7/500 x plus 600. Then of course we need to divide by 1 25/100. Then y equals 7/500 divided by 1 25/100, which is a negative 6/10 x plus 600 divided by 1 25/100 is 480. we're going to label the x-axis our car, miles, and our y-axis SUV, miles, and the title is carbon dioxide emissions. Whoa. Alright, and each interval is going to represent 100 miles. Alright, now we're going to start with the y-intercept, which is 480. So we need to go up to 480. And from there, which is right about here, we need to go down about 6/10 and then over 1. And so your graph would look something like this. Okay, and then we would shade in this region here. Everything on the inside. And that is what your work and your answer for letter A should look like. So what I would like for you to do now is go ahead and pause the video and finish as many as you can with a Peer Buddy. And the answers will be on tomorrow's classwork video.